By Nick Carney, different learning difficulties do not, as previously thought, correspond to specific regions of the brain, new British research suggests. Instead, says a team from the University of Cambridge, poor connectivity between hubs within the brain is much more strongly related to children's difficulties. Scientists have struggled to identify areas of the brain that might give rise to learning difficulties such as dyslexia, dyscalculia and developmental language disorder, or to developmental disorders such as attention deficit and hyperactivity disorder, ADHD. Perhaps, the Cambridge team suggests somewhat provocatively, that's because there are none. To test this hypothesis, Duncan Assel and colleagues used machine learning to map the brain differences across 479 children, 337 referred with learning-related cognitive problems and 142 from a comparison sample. The algorithm interpreted data taken from a range of cognitive, learning and behavioral measures, as well as from brain scans taken using magnetic resonance imaging, MRI. The results are published in the journal Current Biology. Recommended they show that the brain differences did not map onto any labels the children had been given. In other words, there were no brain regions that predicted having ADHD, for example. More surprisingly, the researchers say, they found that the different brain regions did not even predict specific cognitive difficulties. There was no specific brain deficit for language problems or memory difficulties, for example. Instead, they found the children's brains were organized around hubs, like an efficient traffic system or social network. Those who had well-connected brain hubs had either very specific cognitive difficulties, such as poor listening skills, or had no cognitive difficulties at all. By contrast, those with poorly connected hubs had widespread and severe cognitive problems. The severity of learning difficulties was strongly associated with the connectedness of these hubs, we think because these hubs play a key role in sharing information between brain areas, Assel says. This work suggests, he adds, that interventions should be less reliant on diagnostic labels. It's better to look at their areas of cognitive difficulties and how these can be supported, for example using specific interventions to improve listening skills or language competencies. Or at interventions that would be good for the whole class, like how to reduce working memory demands during learning. The findings also may explain why drugs treatments have not been effective for developmental disorders, the researchers say. Drugs tend to target specific types of nerve cells but would have little impact on a hub-based organization. Let's block ads. Why?